So I want to go over integration of trig functions, and the first ones we want to deal with are sine and cosine. So what I've done is I've copied some problems, and I want you to notice a couple of things about these problems. And that is, if you look at this one here, one of the functions has a power of an odd power, the other one's an even power. These two, one's an odd power. They're both actually odd powers. This one here, it's only even. This one here, only even powers. So we have odd powers up here mixed with even powers, and then we have only even powers down here on the second row. Okay, you handle these differently if we have the odd case. So let's look at the odd ones first. Let me pull this one down. Let's work with this one. So what you want to do here is you want to convert that sine squared x cosine cubed into just a function which has a single sine or a single cosine, because you're going to be using use substitution on these trig functions. You're going to have like a product of trig functions, or you're going to have a single trig function. You may have like this cosine cubed x. Whenever there's an odd in there, you want to convert it so that there is just a single sine or cosine, like sine or cosine to the 1 power. So I'm going to take that cosine cubed, and I'm going to make that cosine squared cosine x. That's cosine cubed, right? And I'm going to show you this. We're going to use u sub on this. So now cosine squared is also known as 1 minus sine squared. I'm using the fact that sine squared plus cosine squared is equal to 1. And so if you move the sine squared over, you get cosine squared. And now this is times cosine x, and so we get sine squared x minus sine to the 4th x times cosine x. Now, when you take the integral of this, so this now becomes 6 integral of sine squared x minus sine to the 4th x cosine x dx. If you notice, you can let u equal sine x, and then du will be cosine x dx, and you can replace this whole thing here with du. All right, and so your integral will now become 6 integral u squared minus u to the 4th du, and then you finish it from there. So the idea here is, once again, if you see an integral with an odd power with sines and cosines, you're going to convert it so that there is just a single sine or cosine in this and use u substitution. So let me take this one here and translate it over, and we're going to try that one by itself. All right, so here we are. So what I want to do here is I want to make, let's see, u, well, I can make this sine theta times sine squared of theta, that's sine cubed, cosine to the 5th of theta. And now that sine theta, sine squared is 1 minus cosine squared. Using the Pythagorean theorem, the Pythagorean identity again, this is cosine to the 5th theta. I'm going to move this over here. This is 1 minus cos, I'll show you why in a second. 1 minus cosine squared times cosine to the 5th theta, sine theta. And now multiply that cosine to the 5th through. That's cosine to the 5th minus cosine to the 7th times sine of theta. And now that integral becomes integral 0 to pi over 2, and then this is d theta here. You can let u equal cosine theta, and then du is negative sine theta, d theta. negative. So I'm going to put the negative on the other side. And now this all becomes negative integral u to the fifth minus u to the seventh du. Now I'm going to convert my u values, my theta values to u values so that I can put in my limits of integration here in terms of u. So when theta is pi over 2, cosine of pi over 2 is 0, so u becomes 0. And now when theta is 0, cosine of 0 is 1. So when theta is 0, u becomes 1. So these limits of integration here become 1 to 0. And so I can rewrite this as integral 0 to 1, because when you flip the limits of integration, the negative, you multiply by a negative. So now this becomes u to the fifth minus u to the seventh du, and then you finish it from there. Okay, so, and now when you do this, you can just keep it all in u. Okay, so here a Pythagorean identity doesn't do us any good because cosine squared theta is 1 minus sine squared theta. And if you let u be sine, then du is cosine. Well, then there won't be a cosine left in there. The idea here before was that you let u be a term and then du was the rest of what's in there, okay? We don't have that in this case. So what we're going to use for even powers, so for even powers, exclusively even powers, no odd powers in sight, is the following. We're going to use cosine squared theta is 1/2 times 1 plus cosine of 2 theta. We're going to convert it to that. And then if there's an even power, sine squared theta is 1/2 times 1 minus cosine of 2 theta. This comes from, so you need to memorize these. Memorize. They're used almost weekly in this class. So where do they come from? So why? Well, if you remember cosine of 2 theta, let me do this in a different color. Cosine of 2 theta is cosine squared of theta minus sine squared of theta. This is from trig. But cosine squared can be written as 1 minus sine squared of theta, and then minus sine squared theta. And so this is 1 minus 2 sine squared theta. So if you move things around, so that's equal to this, right? So I'm going to make it 2 sine squared theta equals 1 minus cosine of 2 theta, and then multiply by 1/2. You get 1/2 times 1 minus cosine of 2 theta is sine squared theta. And then you can do the same thing so we've derived this one. You can do the same thing to derive the top one by just taking the cosine squared, the sine squared, sorry, and converting that to 1 minus cosine squared of theta, and then doing the same material, and you'll get that one up top. All right, so anyway, let's get back to the problem at hand. It's 0 to pi over 2 of 9 cosine squared. So we have integral 0 to pi over 2 of 9 cosine squared of theta d theta. So I'm going to pull out the 9, make this 1/2 times 1 plus cosine of 2 theta d theta, 0 to pi over 2. I'm going to pull out the half, that makes it 9. Integral 1 plus 9/2 1 plus cosine of 2 theta d theta. And now this is just normal integration. So this is 0 to pi over 2 still. 9/2, and then theta plus integral of cosine of 2 theta is 1/2 sine of 2 theta, and then 0 to pi over 2, and then you finish it from there. If you have a combination of two, like this one up here, let's pull this one down. Okay, so what you can do is you can make this, so you can pull the 7 out, of course, 0 to pi. And you can make this 1/2 times 1 minus cosine of 2 theta, or you're using t. Make this a little smaller, t. And then the cosine to the fourth is also known as, all right, so cosine to the fourth of t is also known as cosine squared of t squared. So that would be 1/2 times 1 plus cosine of 2t quantity squared. So that would be 1/4 times 1 plus 2 cosine of 2t plus, I'm forming this out, cosine squared of 2t. So now I put all of that here. Let me make this bigger, 0 to pi. And then once you multiply all this out, let me do that real quick. Okay, so what I did was I took the 1/4 and the 1/2, that's 1/8. I pulled them out, multiplied by 7, got 7/8. I FOILed this out, FOILed this with this, and I got all of this. And then I combined terms, and I got what's down here, the final thing right there. Now, this looks pretty complicated, and it can be if you're not careful. This integral is easy, this integral is easy. This is just 1/2 sine of 2t when you do it. Now this one here, you need to use that formula again. So that would be 1/2 times 1 plus cosine of 4t now. So if it's cosine squared of t, that would be cosine of 2t. If it's cosine squared of 2t, that's cosine. You just multiply 2, this number here, times 2, whatever it is. So in other words, if it's cosine squared of, let's say, 6t, this would be 1/2 times 1 plus cosine of 12t dt, or 12t, excuse me. All right, so then get rid of that. Now, this integral here goes back to the previous stuff. Cosine cubed of 2t dt. Now that would be, you're going to make this cosine 2t, cosine squared of 2t, cosine of 2t dt, and now you'll make that cosine squared into 1 minus sine squared of 2t, and then cosine of 2t dt. You'll set u equals sine of 2t, and then du will be 2 cosine of 2t, 1/2 du is cosine, this is dt, cosine of 2t dt. Now, what we've got then is that this is a dt. So that this here will be replacing what we have up here there. And so our little mini integral here becomes integral, so 1/2 out in front, that's that 1/2, 1 minus u squared du. So that's how you're going to take care of this integral. And so this becomes a little complicated, but that's how you start.